Kia ora Year 12 and Year 11. This is an AS question that George asked me about, and it's a good example of the chain rule. So we're going to start by reading it and figuring out what information we've been given, what derivative, and what we're trying to find. So we've got the volume of a balloon, and it's increasing at a constant rate of 50 centimetres cubed per second. And we have to find the rate of increase of the radius when the radius is 10 centimetres. And we're given the formula for the volume of a sphere. So my goal is to find dr by dt when r equals 10. And we're told that dv by dt is equal to 50. We're given the formula for v in terms of r. So v is equal to 4/3 of pi r cubed. So we're going to use the chain rule, and we can pretty easily work out that dv by dr is equal to 4 pi r squared. There's a really nice video by, I think it's by Black Pen, Red Pen, on the sphere formula and how this links into it, if you want to go and watch that, but you don't have to. So what we've got to do is find dr by dt. So we can set this up using the chain rule. Dr by dt is equal to something times something. So we're going to have dr by d something, and we're going to have d something by dt. Right, there are other ways to think about this, but this is the way that I do it because I use this method in harder problems that we hit in A level, where we're going to have 3 rates of change, or 3 derivatives. So in here, what have I got? Well, I've got this, and that means that I know that dr by dv is equal to 1/4 pi r squared. So all we have to do now is to put those together. We get 1/4 pi r squared, and we were told in the question that dv by dt was equal to 50. And this is where we need to substitute in r equals 10, and we get dr by dt is equal to 50 over 10 squared is 100, so we get 50 over 400 pi, which is 1/8 pi. And I think that worked out to be 0.3 something, but I honestly can't remember. I could just peek and have a look at the schedule really quickly. Where is it? Yep, here we are. Okay, so it's 0.0398. And the units are going to be, I think, centimetres per second. Just one thing to note in here, if you have trouble remembering how to do your units, the units will be the units of the numerator over the units of the denominator. And sometimes in harder problems, that can be a good way to remember what's going on. Okay, so that's all for that one. There are lots of other questions like that. So that's kind of about a merit level 3 calc problem that won't come up in level 2 calculus. So if you're doing this and you're sitting in the AS class this year, you need to know this for the Cambridge exam. And it's a really fantastic piece of calculus that works in all kinds of weird places, but you won't hit this in your level 2 NCEA exams this year. George, thanks for emailing the problem. I've got a bit of time now that the holidays have started to make some videos, so please do send in some more by email if you've got questions.